This is the lab demo for Lab 6, and what we'll be doing is working with hypothesis testing this time for one sample tests. And what we'll need to do for 10.2 number 20 is we will use proportion stats. We'll go to Stat, Proportion Stats, one sample, and again we have Summary. This time, instead of confidence intervals, we'll be using hypothesis test. And there are a few things you need to know. What we are given initially is a historic value of 38% of adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. So 38% of adults, that's a historic value from December 2001. Then we also have a recent poll, which is a sample that was recently taken. And what we're going to be doing is comparing this recent sample, this recent poll, with that historic value. The 38%, the historic value, is called the null value. We will place that here in the null hypothesis. So we would put 0.38 here in the null hypothesis. Now, we also need to determine whether we're doing a right or left tail or two-tail test. We'll talk about that in a moment. The number of observations and the number of successes, that would be determined from the recent poll or from the sample that was taken, and those values would then be compared in a hypothesis test to this null value, 0.38 or 38%. Now, in order to determine whether this is a left, right, or two-tailed test, we need to finally read through the problem and see what question is being asked here. We are asked, has the proportion of families with children under the age of 18 who eat dinner together 7 nights a week decreased? To simplify that, we're being asked, has the proportion decreased? In other words, is the sample p-value less than the null value from the historic information? So is the sample showing that the proportion is less than what it was previously? In other words, has it decreased? Once you have that, you can compute, and you'll be getting your, you'll get a test statistic, and you'll also get a p-value. Of course, with the p-value, you can compare to alpha, which is given here in the problem. You're told to use an alpha value, a significance level of 0.05. By comparing the p-value to alpha, you can answer the question about the hypothesis test. You can also compare the test statistic to the critical value from the normal distribution table. So either way is an appropriate method. In the long run, you probably will choose either the p-value method or the test statistic method, which is a critical value method, critical region method. Either method is okay. You will sometimes be asked to use both methods, but that is not necessary. In the real world, you would choose one or the other. Now, the next problem is 10.3, number 24, and for that one we have data. So back from the StatCrunch website, we'll view the data sets from your textbook in StatCrunch, and we'll go to 10.3, number 24. For this one, we'll be running a hypothesis test again. We'll go to Stat. Now this one is for a population mean. For mean, we use t-stats. And again, we have one sample, and this time we have data. We'll select the column that contains the raw data. And then, of course, for the hypothesis test, we need to recognize from the statement of the problem what the baseline value is, or the null value that we need to compare our sample to. Now, in this case, the quality control manager wishes to verify that the mean amount of juice in each bottle is 64.05 ounces. And so what we need to do is set 64.05 as our threshold, our null value. That is the value that we will compare our sample to. So we have a hypothesis test with a null value of 64.05, and what we need to do is determine whether the mean amount of juice is equal to 64.05. So in this particular case, we have a two-tailed test. We're simply testing to see whether the sample indicates any difference from the threshold value. So what we will do is select a not equal to for our alternative hypothesis indicating a two-tailed test, and then you'll click Compute and interpret your results. In this particular problem, the third problem, we are going to 10.4 and we're working with number 10. This would be a hypothesis test for standard deviation, and as we mentioned in Lab 5, variance stats would be used for either variance or standard deviation. In this case, we use variance stats, one sample, and we have summary data this time, so we'll click Summary. Now what we have is we have a previously known value. In this particular case, 0.42 is the previously known standard deviation. Now, 0.42 is the previously known standard deviation, and we want to translate that to variance. As I mentioned before, StatCrunch does not have a separate test for standard deviation, so anytime you need to translate standard deviations and variances, of course, it's either a square or a square root. Now we have a standard deviation of 0.42 as our null value, but here, of course, we have sigma squared is our hypothesis test parameter, and so we need to square the 0.42 in order to adjust for this particular test. And you could do that right here in the in this field, 0.42, and use the caret and a 2 to square the value. Now in this case, what we're doing is we are attempting to determine whether the sample that was taken is indicating a lower standard deviation. Has the standard deviation decreased? And in this particular case, if the standard deviation, change that back to hypothesis test. If we're testing for a decrease in standard deviation, we'll be using a left tail test. So I would select less than. And of course, the sample variance and sample size, the sample that was taken indicates a standard deviation of 0.38. So again, the field is for sample variance. If we have a sample standard deviation, we'll do 0.38, and don't forget to square that so that you are inputting a variance value where StatCrunch expects a variance value. So what we'll do, make sure you have variance in here, input the sample size, make sure you have the baseline or the null value from the previous measurement in the correct place, click Compute, and then you can interpret your results. Now, of course, when you're finished with all of your results, make sure you save all of your results. Make sure you have everything you need. There is one data set you should save for this particular lab. Then you would, of course, go and create your StatCrunch report. Any interpretations or answers to the questions that are in the lab need to be included in the body of the lab, and then you'll attach your results and the one data set, and you should be set to go.